And we are live. Welcome everyone. It's Tech Excellence Meetup, and the topic of today is rewiring your brain with test-driven thinking in C++ by Phil Nash. Hey Nash, welcome to our show. Before I hand over the microphone and before I introduce Phil in more details, let's see who we are. Yes, we are Tech Excellence. Our vision is to raise the bar of technical excellence across the world. Here are our team. We have first and foremost Valentina Jemovic, next to her Alina Liborkina, Oliver Ziller, and Daniel Moka, which is me. I will be the main host of today. And of course, you can join us on meetup.com, and you can also follow us in many social media platforms, in YouTube, LinkedIn, X, GitHub, and we also have a Discord community. Huge thanks to our sponsors, Optivem, Mocha IT, and CodeArtify, and to our partners, QE Unit. All right. And as I said, before I hand over the microphone, just 1 second, because now it doesn't want to. All right. Yes, exactly. Before I hand over the microphone, I would like to introduce them. Phil Nash. Phil is the original author of the C++ test framework, Catch2, and is an independent consultant and trainer specializing in TDD and modern C++. He's formerly developer advocate at Sonar and JetBrains. He has had a career that spans finance, mobile, and software security. Very impressive, but it's not over yet, because he's also a member of the ISO C++ Standards Committee, organizers of C++ London, C++ on C, ACCU, and Swiftcraft, as well as co-host and producer of CVP Cast. Wow. Lot of things you do, Phil. So welcome to the show. And it's time I hand over the microphone, and I wish you good luck.
Thank you, Daniel, and thank you everyone for coming. I mean, I can't actually see anyone, so I'm assuming people are there. So just testing here with this slide. Let me just move on to my real first slide. So as Daniel said, we're going to be rewiring our brains today with test-driven thinking, and in brackets at the end in C++. There is a bit of C++ in here, but really most of this is not C++ specific. In fact, half of it is not even programming specific. So don't worry too much if you're not a C++ developer. Maybe you're just curious about how this all works in C++. We will actually see a bit of that. But as I say, don't worry too much. Everything should be understandable anyway. Now, you may have heard that we only use about 10% of our brains. It's something that we commonly come across. Unfortunately, it's not true. It's been debunked. They've actually done real experiments on this just to make sure that they still parts of our brains light up when we think about particular tasks. So it's a bit disappointing, because that was it's quite a compelling idea that there's all this part of our brain that's just waiting there to be unlocked and to be used and to be more productive. So are there other ways that we can actually use what we do have in our brains to be more productive? And of course, the answer there is definitely yes. And that's something I've been interested in for a long time, as a hobbyist researcher into productivity techniques and brain hacks and those sorts of things. And a lot of those things have become more mainstream in recent years, so I don't tend to talk about them so much anymore. But what happened a few years ago was I discovered that another thing I spend a lot of time on, which is TDD, sort of collided with my interest in productivity ideas and really psychology and neuroscience. So really this talk is about that collision, how these two things meet, how they work together to become perhaps even bigger than the sum of their parts. So I'm actually really excited to give this talk. So we'll get into that. I mentioned C++, just out of interest, because I can see that the comments are coming from YouTube here. There's a bit of a delay, but if you are a C++ developer or you've done any C++ at all, let me know in the chat. That will come through in a few seconds. I'll carry on talking just to get an idea of who's in the room. By the way, if you're watching this later on YouTube after the fact, obviously you can't contribute to the chat, but you can see it. There should be a button somewhere to say, replay the chat, so you can see what people are talking about as we're going through. So I have a little bit of notoriety in the C++ community as the author of a test framework called, it was originally Catch. It's now Catch 2. So if you are in the C++ world, you may have heard of that. And it's actually become quite popular. According to most of the surveys, it's now the second most popular test framework. So quite proud of that. And it means that some people actually think that I'm an expert in testing, which is not entirely true, but I do try to play the role at least. So that's why I'm here. And I do training in TDD, particularly in the context of C++ as well. So do contact me if you want that. And as Daniel mentioned, also run some conferences. So as an independent, that's where I make most of my money from these days, training and conferences. So do help me out by coming along to those. But that's not what we're going to talk about today. We are going to talk about test-driven thinking. Notice not test-driven development, test-driven thinking. That's where the psychology comes in. But we're actually going to start with the philosophy of TDD. And we're going to go right back to the basics here. Fundamentals. We always start with the why, we're told, aren't we? So why do we write tests? In fact, before we even get to that word why, let's even remove that. Just ask the question, do we write tests at all? And I think maybe the YouTube lag is a little bit too much to make this interactive. I would normally ask the audience. But usually when I ask this question, I'll ask, who regularly writes tests for their code, at least in part. And, maybe about 20 to 50% of the audience, depending on who I'm speaking to, will raise their hands. But then I follow up and say, who's currently working on a code base with at least 90% test coverage? And then quite a few hands go down. But I get most people with the last question, who thinks that they probably should write more tests? And almost everybody puts their hands up there. There's always one or two holdouts, but most people think that we should actually write more tests, that we don't write enough. So before we actually get back to ask that why question, maybe we should ask the why not? Or just to include everyone, why do we not write enough tests? So if you did follow that pattern that I just said, most people say they don't write enough tests, suggests that you see the value in writing tests, but that you don't always do it. Why is that? What's the reasons we have for not writing tests? And if you're coming to see this talk or part of this community, you're probably much more focused on quality and testing and excellence than most developers out there. And yet still, maybe we don't write enough. So maybe some of these reasons will resonate with you. This is by no means an exhaustive list. I'm sure you can think of many more reasons, justifications, excuses, however you want to frame it. But perhaps some of these resonate with you, and they certainly resonate, I think, with most developers. Probably the number one is just that it's extra work. You're writing some code to solve a problem. You're not writing code so that you can test it. So, yeah, you probably got some other way in your head of how you want to see that the code you've written actually works. I would hope you're probably not just checking in code that you've never even run. So it's extra work. And because it is extra work, that alone will slow you down. There's other reasons it might slow you down as well. In fact, it might distract you from what you're doing, particularly if you are focused on a complex problem, something that takes a lot of your focus. Then if you've got to switch mindset over to thinking about how to test that code, well, that's a distraction, and that's going to slow you down even more. So these are sort of three very closely related reasons that almost sort of feed off each other. But maybe it's the last one. Maybe you just think that, yeah, I got into programming because I want to solve interesting problems, not write tests. That's boring. So whichever one of these reasons resonates with you, doesn't matter. Say maybe it's something else, but I've picked this list because we're going to come back to it towards the end and see how they stack up. So if there are all these reasons not to write tests that say maybe do resonate with us, then why do we write them? And at this point, we are coming back to the why. So again, lots of reasons, lots of benefits. I'm not going to be exhaustive here. I want to pick out a few. Again, the most obvious one, usually the number one that people think of, we write tests to catch bugs. And certainly that is a very important use case. Perhaps not even the most important. though. We'll revisit that one. But maybe some that are sort of slightly less obvious, at least to most people, is maybe we write tests to encode our expectations. And if you are somebody that writes tests regularly, maybe this doesn't sound so surprising, but for a lot of people it is. But if you think about it, what you're doing when you're writing a test is you're saying, well, this is what I expect my code to do, and I'm going to write that down. I'm going to encode it in a test, relieving me of the responsibility of actually then seeing if it does actually meet that expectation. So that's really important. We'll come back to that a lot. This one is sort of more closely related to the catching bugs, catching regressions. A couple of ways we can define a regression. Obviously, if we've got some code that passes the test and then later we make an unrelated change and break it, then that's a regression. But perhaps some of the usage that most people think of is you found a bug in production, say, you write a test to actually exhibit the bug, then you can make the fix, see the test passes, and then you keep the test in to make sure you never get that bug back again. But that's just one of the two meanings of catching regression. So that's actually quite important. And it's sort of like the mirror image of the catching bugs, or catching the reintroduction of a bug. And the fourth one I want to highlight here, so there's many, many more. And again, one that typically divides people into two camps. There's those that think, what do tests have to do with documentation? And then those that say, well, obviously, tests are a good form of documentation. Using tests as documentation, by which I mean, if you look at the test, you can see what the code is meant to do, is often better than traditional documentation, because the documentation itself is tested by the code. So that the tests test the code effectively tests the tests, and if the tests are documentation, it means it can't get out of sync, unlike written documentation to some extent. So where you can use tests as documentation, that's great. It does come with a little caveat that not all tests are appropriate to use as documentation. Sometimes you're probing at those edge cases that you don't really want people to do, but you just want to make sure it works. So have some scheme to clearly delineate that, and we won't get into that too much. I say this is not exhaustive. I'll put up a few more, still not exhaustive. Many, many more reasons that you can think of, I'm sure. My point with this slide is to show, because you can probably see the subtle difference in colors here. The list on the left, these are benefits that you can get from pretty much any form of testing, whether it's unit testing, integration testing, system testing, you name it. You can make these benefits work to some degree or another. All of the benefits on the right, and if you look at them, they might look a bit stranger, but there are indeed benefits. You can only get if you're doing TDD. So test-driven development, I'm sure we know. Writing the test first is usually the main component of that. If you're not doing that, you won't get any of those benefits. And if any of these look odd now, by the end of this material, they will make a lot more sense, believe me. So bear that in mind. All right, so definitely some clear benefits, but also some reasons you might not want to write tests. So there's some tension here, some conflict. How are we going to resolve this? Well, wouldn't it be great if we could just make all these problems go away? Well, bit of a spoiler. That's what we aim to do. And that's why I picked these four, because I think these are probably the four we can focus on the most in this. But what if I said, instead of tests being extra work, they can actually help you to avoid rework, such that over time, the total amount of work you do is less work. What if I said that instead of slowing you down, they could speed you up? Again, overall, on average. And what if instead of distracting you from what you're doing, they can actually keep you focused on what matters? And we'll dig into that in more depth. And of course, what if instead of being boring, they can actually be fun? Well, I've got some promises to live up to, so that's what this material is going to get into now. So the big question, of course, is how are we going to do that? And if you've seen talks on TDD before, this one's going to be a bit different, a little bit unusual. We're going to get much more into, as I said to begin with, the psychology and the neuroscience of it as well. And I won't keep this slide up for too long because I've been told it's very distracting. So we'll move on. 3 key ways, key areas that we're going to look at. And this is where it's going to diverge a bit from normal. So the first one is going to be habit forming. So pure psychology, neuroscience. How do we form habits? If you've looked into this before at all, this should be quite familiar. Always worth another look. And if not, you can actually learn something really valuable here, completely independent of software development. Taking upper level, I'm going to talk about something called dopamine triggers, how that can work very effectively with the first point, but also on its own. And then thirdly, what I call externalizing your brain. Actually, we talked at the beginning about, using 10% of our brains. Do we have this 90% untapped? Well, actually, in a way we do, because as humans, we're not limited to just our individual brains. We can actually work together and externalize our brains in different ways. And we'll look at what that means a bit later. Before we do get into the psychology and neuroscience, though, I do want to make sure that we are all on the same page when it comes to TDD, what it actually is. So I'm going to have a brief recap of TDD, and I'm going to do that by the means of the tale of 2 cycles. Not these ones. These were my kids actually about 10 years ago, their first bikes. They've got adult size ones now, but the first cycle I want to talk about is the TDD cycle itself. Again, if you've done any TDD before, this will be familiar to you, but I want to go over it again anyway, because there's a couple of bits and I'm going to do a little bit differently to how other people do. So we always start with a failing test. So I've actually put the start in there explicitly, because that's really important. If we write a test and it doesn't fail to begin with, that may be valuable as a form of testing, but it's not part of the TDD cycle. You have to start with a failing test. And it says write a failing test. Highlighted the word failing there, as I said, but also the word test. Maybe we don't want to get too hung up on what that means exactly. So if we're thinking of an assertion and a test framework, well, that's a very common way to write a test. It's not the only way. At anything that gives us feedback, anything that allows us to encode that expectation in a way that can give us feedback when we've either met it or not met it, can act as a test. And if you're using a compiled language, and we're going to talk a little bit about C++ today, a compiled static language, then the compiler itself can be a type of test framework. And there's other things we can do as well. I want to sort of get at the generalization of this, because we're talking about test-driven thinking, not just test-driven development. But even within TDD, test-driven development, more than just unit tests we're talking about here. Once you have that failing test, only then you go on to the green step, where you can write just the code to make the test pass. Again, highlighted the word just there. This catches out even experienced TDD practitioners sometimes, because, intuitively, we want high quality code. We want well-factored code, pay attention to cohesion and all of these design principles. We're not going to get into in this particular talk, but we don't do that here, not at this step. We just want the simplest, easiest way to get all the tests passing. Because then we have a separate step, the refactor step. The next one, which we only move to when all the tests are passing, where then the only thing we're concentrating on is refactoring to a cleaner state, where we do pay attention to design principles, how the whole thing hangs together, duplication, and all of that sort of thing. We do that at the refactor step. And then where I slightly diverge from many other renditions is I'm explicitly putting the are we done step on here as well, because it might seem obvious. It's easy to overlook this, like, well, surely when you're done. There's a reason I particularly pull it out here, we'll come back to later. But even just the fact that by following this process, it does keep you more focused on what you're doing at each stage. So when you ask that question, you're not thinking so much about, well, what could I do next to make things even better? You're thinking about, what do I actually need next? but we'll come back to that. So really that, in a nutshell, is TDD. A lot of the nuance goes on between that, of course, and this is why I do a 2-day workshop on TDD. Takes a bit of practice and experience, and there's more that's not on this diagram, but that's really the high-level overview. So let's see this in practice, and this is where we'll finally see some C++. So I'm going to do, as is tradition, a coding kata, and for this one I'm going to use leftpad. So you may remember some years ago there was an incident where this JavaScript library called leftpad just pads the left-hand side of a string with spaces up to a certain size. It was in the news because the author of it had some dispute with npm, the package manager, and they ended up pulling the library out. Fine, sort of thing happens all the time, I'm sure, except that then half the internet stopped working because it turned out they were transitively depended on this tiny little library. And part of the discussion around this was people saying, why there's so many libraries out there all depend on this tiny little library for left padding strings? Surely anyone could write this themselves. So let's do that then, but in C++. So as well as seeing C++, we're going to see catch2. So it's still the catch.hpp header. We include my test framework. And in fact, just writing this line of code is already a test of sorts. Okay, if you've ever used catch before, you'll know that there's something you have to do somewhere else to make this all work. But this is actually a program that has no test in it. And you can run it and you can verify that. Doesn't sound very useful at all. And to be fair, I wouldn't normally do this, but just to demonstrate this idea of writing a test and getting feedback. By doing that, we've actually now got the feedback that this is running exactly as we expected it. No tests, we didn't expect any, but everything else works, which means that every increment on from here, we know exactly what we've done and what we expect to happen. And that's really the secret tool of TDD, is taking these tiny little baby steps and verifying every step of the way. So let's take it a step further, and we'll add a test case. So this is how you do it in catch. So one of the nice things is that test names are free-form strings, so you can have spaces and punctuation and so on, which is nice. Again, we could actually stop here, build and run, and we've got some different feedback. So we know we're on the right track. We have a test case, there's no assertions. We can actually go even further if you want. There's a command line argument you can pass to it that will actually report this as an error if you have a test case with no assertions in it. Up to you if you want to do that. But now we have a failing test. We can actually write just the code to make that pass. It sort of brings out the what people initially see as the absurdity of the TDD process, that we write code that we know is not what we ultimately want. It's just a baby step along the way. But that's what this is. This succeed macro here is just making the test pass, even though it's not actually verifying anything. What it is doing is showing that what was making the test fail before is exactly what we thought it was. Valuable information. So I wouldn't do this part every time, but sometimes, like if I'm setting up a new environment, for example, I might actually do that. All right, let's write an actual test then. So require is the assertion macro in catch. And within there, I can just write free-form C++ code. Notice I don't have to separate the left-hand side and right-hand side and do like a require equals or something like that. And actually, catch2 behind the scenes is breaking that down into left-hand side and right-hand side, so it can report the independent values. But that's not this talk. So we're requiring that there's a function called leftpad, which takes a string and an integer and returns a string. Now, one of the things we should always do with TDD, where possible, is when we're choosing values to pass and to check, start with the simplest possible values: empty strings, zeros, null pointers, empty optionals, anything like that. So that's what we're doing here. Empty string, 0 pad length, and empty string return. Fine so far. And that's already a test. It's a compiler test. As I say, C++ is a statically typed language. So the fact that there's no left pad function means that it does not compile yet. That's a failing test. We can go around the TDD cycle. So to make that part, well, actually, before we can get there, we don't even have to compile these days. Most IDEs, if you're using an IDE, will effectively compile in the background and tell you that left pad doesn't exist. That counts as a failing test. So to make it pass, we can write a left pad function. So again, C++ syntax, just to sketch in. So stood string is the main string type. String view is like a non-owning view of a string. Reference semantics, if you like. Don't worry too much about that. They're both strings. And then size t is just an unsigned integer. And the empty curly brackets means whatever the return type is, the default constructed one of those, which is going to be an empty string. So if we run that, I mean, that compiles and then passes, all the tests pass. Great. That's the TDD cycle, isn't it? We saw a failing test, we wrote some code to make it pass, and now we see all the tests passing. This is one of the little subtleties that I mentioned. We've actually done 2 steps here. There were 2 tests hiding in this code. There was the compiler test to say left pad doesn't exist, and then there was a runtime test to say that left pad has the behavior that we expected. And we just blasted through the second one. And the problem is, and this is something that you do come across a lot, where you're trying to use the simplest possible values like empty strings and zeros and nulls. We do that in the test code as well. In fact, the code under test as well. If anything, it's even more important there because, as you will see, we'll want to progress through generally more generic code. So we start with the empty string, which is what we expected. But that means we never saw that runtime test fail. To do this properly, what we need to do is make either the code under test or the test code deliberately incorrect. So we can see it fail, then fix it and see it pass. Again, if you find that ridiculous, hold the fort. Let's follow the process and see where it takes us. The question is, which side should we change? And to some extent, you could change either side. I always prefer to change the code under test because when I write a test, I want the test as much as possible to always be correct when I write it. So the left pad of an empty string with a 0 pad length should be an empty string. That's it, it's done. Whereas the code under test, that's the thing that's evolving. That's the thing that we're growing using TDD. So we'll start with that having an incorrect value. Doesn't matter what we put there, as long as it's not an empty string, X will do. And now, of course, the test fails. As expected. And just changing it back, now we see it pass. Great. What did that really give us? Well, we'll tackle that in a moment. What I do want to point out is, obviously I'm simulating live coding here with my slides, but in practice, the compile, rebuild, run loop here is not much slower. It takes seconds to see that feedback and then move on. But those seconds buy you the confidence that what you think you're testing, you're actually testing. What you think you're implementing is what you're actually implementing. And we'll see more of that in a minute. All right, let's write another test. So now we will have a non-empty string passed to left pad, keep everything else the same. So we expect that to return effectively the input string, an A in this case. Of course, it fails because we're returning an empty string. So now we need to write some more code to make that pass. Again, just the code to make the test pass. We're not going to jump ahead. So really, we just want to return the string that was passed in. Again, because it's a string view passed in, we need to construct a string from that. But that's what it's doing. It's just returning the string that was passed in. That passes, and the original test still passes. So obviously that's important. Once the test is passing, as part of TDD. It switches from being something that is encoding your expectation to a regression test. Okay, but we know that we don't have the implementation we want yet. That forces us to write another test. So we can go different ways here, and we'll revisit this in a moment, but I'm going to choose to go back to an empty string and now have a non-zero pad length. So a 1 here, we're going to pad an empty string with 1 character, so we should get a space back. Okay, obviously we're not, because we're just returning the input string. Now we need to add an if statement to check whether our minimum length is less than or equal to the input string length. Notice the if case is our original code, just returning the input string. And now the else branch is our new code. And because it's new code, we go back to the same principle of starting with the simplest possible values. So in this case, the just returning a space, hard-coded string. Doesn't seem very general, it's not. And this is starting to give us a clue as to why we do it this way. Because if we jump to the most general case, then it's going to pass lots of tests all at once. But by starting with the more specific and the simplest values and getting to more and more general, we can continue to write tests that fail first time, as we just done. Because now I can write another test that has a different pad length, and now that code fails. Now we have to make another change. And if you know C++, you'll probably know that std string has a constructor that takes a character and a repetition of that characters to give you a string of that number of characters. And if you're like me, you'll usually write it like this first time, which is of course wrong, because the argument should be the other way around. And in C++, a string and a character pointer can coerce to each other. So it compiles and fails at runtime, but we have a test, so we catch it straight away. Excellent. So switch that around. Now it passes. Great. Okay, we're starting to get there. Now we have both branches of the if covered, or do we? Because what we haven't done is combined a non-empty string with a non-zero pad length in our test. So we'll write one of those, do ABC and pad length of 5. We should have 2 character prefix. Whoops, that fails, of course. So now looking at the else branch, all we've done is we've created a string the length of the pad length. What we need to do is subtract the length of the string from that and then add the string as a prefix, something like this. Okay, that now passes. Great. And at this point, we could say the implementation is basically done. At least it works. We can certainly add more tests. You might want to do that. But what you'll find is those tests will always pass first time. So in terms of the TDD tests, we probably are done. But looking at the code under test, well, there's some things that we could do there. There's some redundancies in there, like I've got the conversion to std string twice, and we've got min length and std.length mentioned together twice. So what can we do there? Well, let's look at the min length minus std length first. What does that even mean? So you could say that's the pad length. The pad length is what our minimum string length is minus whatever the actual string length is. If I extract that out and give it a name, that's the refactoring. Maybe that makes the code a bit clearer in terms of the intention. Doesn't change much else. But now we can see up there we got min length minus std length, and min length is less than or equal to std length together. Is there some way we can combine those? And also, is there a way to get rid of the if statement? If statements sort of contribute to the complexity of the code. So if we can reduce that at all, that's better. We could take the max of 0 and min length minus stride length and make that our pad length, and then we can always construct a prefix with that and just add it to our string once. That seems like a good idea, except of course it doesn't work. And again, even if you do know C++, this one might take a little bit longer to reason through, but yeah, mixing signed and unsigned is often a bag of hurt. So the problem is we got 2 unsigned integers and you're subtracting one from the other, and of course that's wrapping around when it becomes negative. So we just need to, in this case, make stud max use an integer. Don't worry too much about the syntax, that's what it's doing, so that if it does become negative, it stays actually a negative number, and then we get the max of it, and so therefore 0. And fine, and that now passes. So there may be other refactorings you want to do. Perhaps you are refactoring for performance. That can happen too. This may not be the most performant way to do it, but we've got our set of tests. The main thing I wanted to really highlight here, even if you've actually got a little bit of experience with TDD, is one of the big challenges of doing TDD is in taking these baby steps. We can often find that we have to take a big step in order to make a test pass, and then we find writing further tests or pass first time, whereas we want to start with a failing test. So you have to think carefully about the values. We will start with the simplest possible values, hard-coded constants or literals, moving up to variables, if statements, and so on. This is something called the transformation priority premise. Robert Martin first wrote about that. So look that up if you want to know more. That's the main approach we have to counter that particular problem. And that allowed me here to actually write 5 tests that failed first time. And when I do this in my workshop, most students will actually start skipping ahead even after the second test. So that in a nutshell is TDD and an example of it. This was the TDD loop. So I said that there were 2 cycles. The TDD loop or the TDD cycle is the first one. Now we're going to change gears a bit just to push the cycle pun a bit too far and look at the second cycle. And this is where we get into the psychology. So take a moment. Habit forming. Why are we talking about habit forming here at all? Well, let's say that, because we've only covered TDD briefly, but let's say you're convinced about TDD. Yes, I want all the benefits. The only trouble is when I get to my real code, I just fall back to old habits. Keyword there is habits. They really are a powerful thing that can really stop us to adopting new practices where we are following these deeply ingrained habits that govern what we do and how we do it. So we need to take a step back and think what the anatomy of a habit actually is. And if you haven't looked at this before, this can be really insightful. So what we think of as a habit usually is actually just one component of the habit cycle, and that's the behavior on here, sometimes called the routine. It's the thing you actually do. So if the routine is that when you're watching TV at night, you go and get some snacks, well, the going to get the snacks is a habit. And maybe that's something you want to change. It turns out habits are really, really hard to change. In fact, the first approximation, they are impossible to change once they're ingrained past a certain point. Instead of breaking habits, you have to change them to change a routine to a new routine. To do that, you need to identify the cue and the reward. And they're a bit harder to identify. So the cue or the trigger is the thing that happens that you then perform the routine in response to. So in our example just now, you're watching TV in the evening. That's your cue. When you perform the behavior or the routine, you go and get some snacks, we get some reward. It could be quite nice to have some fast food snack while watching TV in the evening after a long day. Why not? The trouble is, once you've done this a few times, that habit becomes so deeply ingrained, you don't even need the reward. Even if you didn't enjoy the snacks, you would still follow the habit because it's just this pre-programmed routine. And what's actually happening in your brain, you probably heard this, it's not even an analogy, it's pretty much the fact. Our brains are big association machines, just webs of interconnections, and it's how those things are connected that sort of wire us up, make us do things. When you're creating a habit loop, you're creating a pathway between neurons. And the more you tread that pathway, like walking across a lawn, you're actually literally creating a pathway and maybe digging it into the ground over time. That's why it's so hard to change. But if you can't identify the cue and the reward, it could be really hard to change. So you might need to do some extra thinking in order to get those. But once you've got them, you need to create a new habit that replaces the old one, which means associating a new behavior with the same cue to get some compatible reward. So what's this got to do with TDD? Well, when you want to write some code, you want to write it with tests first, following the principles of TDD. And perhaps the reward that you get, perhaps the reward that you've always got when you just hack some code out, for example, is that you get some immediate positive feedback. Like if you started out as a hobbyist programmer, for example, maybe you got that first buzz out of writing some code and then seeing it work. It runs and it actually does something. You think, wow, that's amazing. All I have to do is write this text in and all this stuff happened. That's your immediate positive feedback. And it could be really rewarding. And over time, even without that reward, well, you still want to follow that same routine. But now you want to write with tests. So we need to identify the cues when you want to write some code. You want to get that same reward, immediate positive feedback. Great thing is with TDD is that when you see a test pass, you usually get some sort of visual feedback. And that might just be something on the command line says, okay, but usually you're going to use something more visual, at least a splash of color, some nice green or a big tick box or something like, everything's great. It seems like such a small thing, but it only takes a small thing. Just make sure you notice it. Make sure you allow yourself to feel rewarded by that. Don't have to go over the top, but just like, hey, yeah, it did work. Great. So because the TDD cycle, you can go around so quickly, often in seconds, you can get lots and lots of these tiny little micro rewards. Pay attention to them, look forward to them. Anticipation is a big part of it. And allow yourself to anchor yourself onto that new habit. And after a while, you'll find you won't even need that reward anymore. That behavior will just become ingrained to the point that this actually comes with a warning. Because it's hard not to follow a habit, as we know. If you apply this to the practice of TDD, you will get to a point, believe me, because I'm there, that you will find it hard not to write code without using TDD to do it. Now, that might not sound like a bad thing, and I don't think it is, but I think it's fair to warn you up front. There's like a meta benefit to this if you can get to this level, because there are other challenges to TDD. And in particular, not all code is as amenable to TDD as these small self-contained examples would seem to be. Sometimes you have to be a bit more creative to be able to achieve it. If you have that extra motivation, because the only way you can really think about approaching code anymore is to do TDD, you will find ways around those challenges and you will get more code under test, which will lead to further benefits. Okay, maybe you're not convinced yet. Let's take it up a notch. Talk about dopamine triggers. We all know about dopamine, I'm sure. And in fact, if we look on the Wikipedia page, it says in popular culture and media, dopamine is often portrayed as the main chemical of pleasure. One thing we didn't talk about in the habit loop that I should have there is that another principle of neuroscience or psychology, at least, is the pleasure pain principle. You've probably heard of this. The idea that as animals, as we are motivated to move towards pleasure, particularly immediate pleasure, and away from immediate pain. Served us very well through most of our evolution. But now it sort of gets us into bad habits quite often. So this moving towards pleasure fits quite right in with this Wikipedia quote. But there is something that seems a bit off here. So it says in popular culture and media, dopamine is often portrayed as the main chemical of pleasure. Does that mean that it's not actually the main chemical of pleasure? Well, yes and no. If you continue the quote from Wikipedia, it says the current opinion in pharmacology is that dopamine instead confers motivational salience. What does that mean? Well, let's break it apart. Motivational, we understand that. We've really talked about motivation, motivated to move from pain towards pleasure. In fact, the motive part of motivation has that sense of movement, the root word there. What about salience? Now, I don't know how many native English speakers are watching, and even if so, how familiar you are with this word. Not everybody is. Maybe you're more familiar with the word salient. We can talk about the salient facts, which means the important facts in a situation. What are the salient facts here? Maybe you've heard that expression. And salience is really just an awareness of the salient facts, an awareness of what's important. Because we're not always aware of what's important around us. Sometimes we have to be primed, put into that state of mind where we are more aware of things. That can happen in different situations. They did a series of experiments with, of course, trained monkeys. It's always trained monkeys. They trained this particular monkey to pull a lever. And every time they pull the lever, they'll get a reward, bananas or something. But then they strap them up with probes that could measure their dopamine levels. And what they found was that initially the dopamine levels would go up because they were getting rewarded, and that was expected. But then it sort of tailed off after a while. And then at that point, they also stopped pulling the lever so much, as if they'd got everything they needed for now. And they knew anytime they'll pull the lever, they'll get the banana. So, why bother now? I could do it later. They already knew the salient facts. That they'd identified the pattern. That was it. So they did another experiment where they delivered the reward, but only 50% of the time at random. And then what they found was that the dopamine levels shot up and stayed high, as if the monkey was constantly trying to find out what the pattern was. What is it I'm doing that gives me the banana? Because I need to know what the important facts here are so I can keep getting this reward. That's the motivational salience, the motivation towards that reward, not necessarily the reward in itself. What does this have to do with TDD? So again, when you are writing a test and the test fails because you expected it to, you write the code to make it pass and it passes and so on, it's great, you get the little buzz out of seeing it pass, but every now and then it doesn't. We even saw in our example earlier, a couple of times it would fail. And you think, oh, what happened? Well, after that, repeated pattern of getting the reward, and you get something different. Well, now that's where the dopamine kicks in, because you want to find out how to get the reward, how to establish the pattern or work out what the important facts are. What went wrong? How can I fix this and get that reward? You're primed to be able to look into puzzles and effectively debug. It's like the perfect storm. So dopamine triggers are both a ratcheting effect on the habit building and also a thing that adds an extra sense of fun to the whole process. So that's motivational salience and dopamine triggers. Here are some of the things that give us that when doing TDD. We already talked about, well, seeing the test pass in the first place, but like the initial monkey experiment, maybe that loses its appeal after a while. But when every now and then you get red instead of green, well, that breaks the pattern. The whole race to green, the writing the simplest thing to make the test pass. Yeah, sometimes that can be fun as well because you're not quite sure how that's going to work out. Or doing a risky refactor. Is it going to break anything? Yeah, all of these things add that element of fun that brings the dopamine in, that gives you that mental state where you're primed to actually identify the patterns. So again, be aware of this and go with it, because this will help you to amplify all of these factors together. All right, last of the 3 sections, externalize your brain. So again, going back to evolutionary biology, as humans, we are what we call open loop beings, in that while we have brains and we can reason and think for ourselves and even, survive on our own, we thrive in the presence of other people, as if we are part of something bigger than ourselves, like not necessarily a hive mind, but we feed off each other. That's this open loop principle. And we've been doing that for millennia, all of humans' existence. More recently, maybe the last few thousand years, we discovered that we don't even necessarily need other humans to benefit from the open loop principle. So we can have thoughts and we can write them down. And in writing them down, that frees up part of our brain from having to hold on to that. So we can put new thoughts there and then bring those things together. So writing things down can actually help us to think even more. Even more recently, we've been doing that with more and more advanced forms of technology. These days, it's putting it to ChatGPT, I suppose. So the idea here is you're effectively like serializing parts of your brain, freeing it up to think about something new instead. So let's bring this back to the TDD cycle. We talked about the different stages in the TDD cycle. We can actually divide them up into what I call 3 separate mindsets, because we effectively take on different roles as we go through this. The first mindset is this high-level design and requirements mindset, or user experience, in the sense that you are using the code that you are trying to test, which is a different way of thinking to actually implementing it. So far, so good. Then we move to this green stage. As I said before, race to green, hacker. You're just implementing, you're not worrying about the requirements, and you're also not worrying too much about design, cohesion, and that sort of thing. And then the third stage, low-level design, clean code, design principles, all of that sort of thing. That's the only thing you focus on. At each stage, you're focused on one thing, one mindset at a time. And it can actually be quite hard to move between different mindsets, but we often struggle with that. That's where the externalize your brain bit comes in, because when you do go back to the high-level design stage, by encoding the requirement in a test, it frees up that part of your mind from having to worry about it. You can then more seamlessly move in to the low-level implementation mindset. And then once that's all green again, you're free to switch over and start thinking about, well, how can I design this better? This doesn't happen straight away, and it can take a little bit of practice. But once you give yourself the permission almost to make these transitions more swiftly, you will find you can move between them much more quickly and much more seamlessly, because you've got these sort of mental save points in between. From the refactor step, you can always go back to the last time all the tests were passing. It gives you greater freedom to make changes. At the implementation stage, you can do things that you wouldn't normally consider to be good programming, because you're just having some fun here, just making the test pass. And finally, this is why I said the "are we done" step is worth highlighting on its own, because you see it's back over the line. When you've gone back into that high-level design and requirements mindset, rather than thinking about the low-level code and what can I do next that would be cool, you're thinking, what's actually the next requirement? It could be hard to be disciplined in that way if you're not in the right mindset. So that's the 3 areas of psychology and neuroscience that I want to look at. Habit forming, so taking what we have decided we want to continue with TDD, how to actually build that into a habit and dislodge old bad habits. Dopamine triggers to make that more fun, take it to the next level, make the habit really stick. And then externalizing your brain to actually effectively get a bigger brain to apply to the problem. So going back to our list of objections that we looked at right at the start, hopefully we can see what we looked at. Well, they distract from what you're doing. The externalize your brain really addresses that. Instead of distracting you, actually helps you to keep you more focused by giving you these mental save points. You don't have to be distracted by other bits of the same process. And instead of being boring, it's fun because of the dopamine triggers. What about the rework and the slowing you down? So getting short on time, but I think we've just got time, as it happens, ironically. Let's talk about speeding up. You've probably heard of shift left testing. So this idea that we move testing back earlier in the process, mostly a reaction to how we used to do things in the bad old days. Leave all the testing till the end, maybe to another team. No, let's move it earlier in the process. And I actually traced the term back to this 2001 entry in Dr. Dobbs' journal from Larry Smith, shift left testing. But the idea itself is, of course, much older. And I think the first I saw of it was probably in Code Complete. And I think I've got it on my bookshelf. I'm just pointing just there. You probably can't read it. That's the first edition. There's a later edition as well. Still a good book, even if it's a bit old now. The principles haven't really changed much. But you've probably seen a graph like this, if not in this book, somewhere else. The different stages of the software development lifecycle, and the cost of making a change at any particular stage. And usually that cost is the actual financial cost, but it's also the cost in time. The later you leave it, the more time and more expensive time it's going to take. And so therefore, the more we can shift things left across this diagram, the cheaper in time and money it's going to be. So in that sense, having testing earlier before we actually write the code has got to be better, where it's the cheapest to actually discover issues before they even get into the real code. And in fact, they're so cheap that we, to quote the Agile Manifesto, embrace change. So rather than trying to write code that is the final code straight away, we incrementally build it up in baby steps, see it fail and then pass, fail and then pass. It's so cheap that it becomes part of the process. But there's more. For this one, I want to ask a question. And again, I'm not going to make this interactive. I normally would. But simple question: why do cars have brakes? Maybe you've seen this before, but even if not, the fact that I'm asking this question in this context, you're looking for the trick. But if I was just to ask you this randomly at some point, you might say, to stop or to slow down. That's what you use brakes for, isn't it? But actually, the answer I'm looking for is so we can go faster, so that you can drive faster. Because how fast would you drive a car if it did not have brakes? Probably not very fast, I'm hoping. Obviously, the analogy here is that tests are like the brakes. They're not meant to slow us down, they're actually meant to speed us up, because if we do make a mistake, if we do break something else in the code base, the test will stop us when we need to be stopped, so we can fix it there and then and be pointed to exactly what needs to change. So we spend minimal time fixing problems and no time at all worrying about what we're going to break, because the tests have our back. There's a lot more I can say, but I am at time. So hopefully I convinced you, at least partly, that all of these things are true. But in any case, that has been rewiring your brain with test-driven thinking in C++. So thank you very much for listening. And Daniel has popped into the chat to see if there's any questions.
Awesome. Great presentation. Thanks a lot. I really enjoyed it. Especially, I loved it. Actually, I really like the fact that you brought up this fun thingy, namely that writing code with TDD is much more fun. And that was also one of the biggest realization for me in my career, that people who don't use TDD, they just write tests after the fact, that they don't like writing tests. Yeah. And yeah, they do it because they do it after the fact, because they do it only for verification, right? Yeah. But when we write tests with TDD, we write tests, before writing code. So we use it for designing the software. And it's really, and also with all the, what you mentioned, with all these passing tests and refactoring without breaking the code, etc., it makes it way more fun. So every developer should realize that writing tests is fun if you use it with TDD. So that was a great point. And also I really like that in the coding, it was a great coding example with these slide sheets. I really like that. And also that you did some mutation testing. Namely, you did some manual mutation testing, right? Remember that replacing the empty string or that default constructor, you replaced to an X, and there was a failing test. And that's what also TDD helps, right? It results in a code which is 100% covered by your test. And here I talk about mutation score, mutation, so behavior coverage instead of code coverage. So TDD is a big help for that. So again, it was a great presentation, and we have a few points and questions, so we can go through them. Let's start with the first one. So here, just a remark from Quinn. He was very active in the chat. He really loved it, actually. He says, the business pushes so hard that thing they need to skip testing and get the code out the door. So what is your experience of this? Whether you had similar experience with this pressure, how did you overcome, or what is your take on this?
So a couple of things. I think first of all, the big mistake here is actually letting the business know that you're doing the testing. TDD as a practice is part of your development practice. It's part of writing the code. It's just an approach to writing code. It's not something extra you do. That's why we can say it's not extra work. It's part of the process that makes you go faster. And even if you can't convince them, it makes you go faster. Your delivery should actually tell the story. And if you're delivering faster, it doesn't matter how you do it.
I totally agree. Writing tests is our territory, and managers should have nothing to say about it, right? We do it as a part of being a good software professional. So yeah, it's a very good point.
And without tests, you can't really verify that you've actually written what you expected to write. So another way to go even faster is just to not write any code. So maybe that's what they want.
Exactly. Yeah. So yeah, definitely. Here there is a question from him. He asks, in C++, do you keep the test cases in the same module as the source code it's testing, or not?
I personally don't, and I think general practice is we don't. But it's not out of the question. And there is a framework called DocTest that's sort of largely inspired by Catch, but it's much more of an emphasis on compile time performance and runtime performance, so that you can actually include the the test right alongside your production code and run it at any time, even out in production, if you want to. And it gets its name from the Python framework of the same name, but the idea being you've got documentation in the form of tests right
Mhm.
alongside the production code. So it is a thing. But I would say it's not the mainstream right now.
And maybe you could answer that why do you keep it separate, or why it is wise to keep it separated? Because there are multiple benefits, I guess, for that. So maybe you could highlight that a bit.
Yeah, I think mostly because if you're writing C++, and it's not always actually true in practice, but at least the perception is you're writing C++ because you want performance, you want your code to be low level, you want to have total control over everything. So you want your final artifact, your binary, to be as small and as fast as possible. So strip out anything that's not necessary. So we usually have a separate debug and release build, sometimes even more of those, but the release build would be the heavily optimized with no debug symbols, and then the debug build has all those things, but it's not what you actually expect to deploy. So the test will be like extra code that's not actually needed in the final release.
Absolutely, totally agree. It's not part of the executable runtime or artifact. So, but still, and also separation of concerns, right? So,
Right.
Also in other languages, I see it maybe in JavaScript over there. They many times they put it next to it. Not everyone, but I've seen it.
Yeah, there are pros and cons both ways. Yeah,
Exactly.
there's another thing that I do. I wouldn't say this is really a mainstream TDD practice, even in C++, but I found it useful that as I'm writing new code, I will write it entirely within my test code. So my test project, test file, I write the new code there right alongside it. And then when it's sort of ready, it's like I'm growing it in a little nursery. And then when it reaches a certain level of maturity, I'll transplant it over into the main code base. And I've got a little bit of extra work to do to sort of wire that in, make sure I've got all my hash includes and any other dependencies all sorted. So it seems like a bit of extra work. But the reason I like to do that is because that does give me a point where I get to re-examine what all of my dependencies are. What's this actually costing me? What dependencies have I brought in along the way that I no longer need, which could be a big problem in C++ code, because those dependencies are usually expressed in these hash include files that get textually included into your final source file and really slow the build down. So getting to re-examine all of those things just makes me a bit more mindful of what I'm putting in, and a chance to strip out things that are no longer necessary. So that's another benefit from having that separation.
Yeah, very good point. I know it's. I remember that also. It's another good point is that let's say if you put your test next to your code, then you are more likely to write test coupled to the code structure because when it's very close to it, you can also easily access it, right? You can access sometimes private methods if you write it next to the next to the class, and if you put it in a different assembly or artifact or whatever module or project, then it's more difficult to write tests for private function or protected functions or such. So it helps you. No, it doesn't enforce, but it helps you to write tests to the public against or coupled to the public APIs and the behaviors of the public APIs. So it's another good benefit, I think.
Yeah, absolutely.
Awesome. So yeah, put your test next to your side. I mean, in another project. That's I would say one of the best practice. Yeah. Here's another point that mentally. So TDD, of course, mentally it forces you to think about breaking down a complicated problem into solvable smaller steps. Helps break mental story blocks. So maybe what is your take on it? Or could you please tell us more?
100% agree. In several different ways. One of the things I mentioned a few times in this material was about taking the baby steps. Like each small increment is really like ridiculously simple, and do you even need to think about that? But if it's just a whole series of baby steps, you can actually cover a lot of distance with that alone. But the other thing is, I often get the complaint that anytime you watch a talk on TDD or read a book or article or whatever, you're just using these little toy examples. What about real world code? And certainly there are some real world code challenges that are not captured in those. But I think maybe the bigger point is if you follow TDD, much more of your code becomes like toy code examples. You want to bring the real world code and make it more like toy code rather than the other way around. So yeah, absolutely. By breaking those complicated problems down into these smaller steps, you actually make things look trivial because they are, and that's what you want.
Totally agree. Yeah, TDD helps reducing mental load. And there is a great analogy for this. I usually use it like, there are jugglers who play with the balls in the air. And the question is, can a juggler hold 7 balls in the air? And yes, they can, but it's difficult and easy to fail. And the same happens when we hold a lot of things in our head, right? It's easy to make mistakes. And that's where TDD helps. It really helps us focus only one small little problem at a time. So it reduces complexity.
Yeah, and there's a meta level there as well that I think you were alluding to, which is the interplay between components in your code. One of the reasons that TDD really works, and we didn't really get into it in this talk, is the impact on your design. That it will lead to a more cohesive design with good separation of concerns and being well factored. That doesn't happen by accident. You actually need to do that deliberately, but it will tell you when you got it wrong. But the reason those are the right design principles is because that's what will lead you to a design that is composed of simpler parts. And I think it's Gaull's law that a complex system that works is inevitably seen to have derived from a simpler system that worked. You take those simple parts, you put them together in a composable way, and you'll end up with something that's still simple to reason about and also easier to test.
Yeah, you bring up a very good point about this design, because many people think that TDD helps designing the software, but it won't tell you which design patterns to use. It won't tell you how to name your components, right? So TDD gives you feedback of the design, and it gives you quick feedback. Right. So that's what a lot of people don't realize. I mean, non-TDD practitioners. Yeah.
You often hear practitioners talk about listening to the tests, and that's what they mean.
Exactly. The best. They are the first users of the code and the feedback of the design, feedback of the public APIs and how it can be used, its name and everything. I would say, and you also brought this up that tests are the users of the code, and for me that's one of the main benefits of TDD. That really I already start using the code before even implementing it, right? So it's I can already prevent myself doing from a lot of design mistakes because I already start using the code before even implementing it. So that's one of the main benefits of TDD. Great. So here there was a thing that you talked about dopamine, and Peter. Hey Peter, nice to see you again. He has a remark question that, hey Phil, I do get the dopamine. What I do not get is why the rest of the developers I work with do not get it. Any ideas how to get more people to do TDD? So
yes, great get them to watch this talk.
First of all, exactly. But so what is your experience with this, or how do you do it in teams, or how you do it?
Yeah. I mean, honestly, that is one of the reasons that I put this talk together, to try to address that point. It's only part of it though. If you're in a team and you're the one doing TDD, nobody else seems to get it. First of all, persistence, keep going. People will start to notice that you are delivering in a different way, probably lower defect rate and better designs and so on, and they'll be curious. It won't happen straight away. Well, it might do if you're lucky, but over time, sometimes it could be years, but it does start to happen. And I have had that experience. I worked on teams that were very resistant to it to begin with, but I kept plugging away, and they realized that no, that there is something in this. Can you tell me more? It's also one of the reasons I actually originally wrote the Catch, the test framework, because there was already, I think on Wikipedia, there's something like 88 C++ test frameworks, so just listed on Wikipedia. Why another one? Well, the reason is that the main ones that I saw at the time, they were just very tedious to use. What you might expect from a C++ test framework. A lot of ceremony and not really taking full advantage of the language. So I really wanted to try to simplify that, so you could write test code that was just test code and nothing else. And that reduces the barrier to entry for a lot of people. So if you're doing C++, then try Catch, and that may bring some of your colleagues along.
Yeah, I'm not a C++ developer, but I really like this framework. I mean, by reading the code and all these things, I mean, by reading the test, I mean, it looked quite intuitive. So once I will use C++, maybe I will give it a try, or I will surely give it a try. Another thing about this topic that surely, I mean, getting more people to do TDD, surely we shouldn't be a top-down approach, right? We should never force people to do TDD. There's nothing good coming from forcing people to do that. The best is to make them understand the mistakes they make and why they are struggling with different things. So they should really realize that, hey, there is a problem to fix, and TDD is the tool for that. And of course, it takes effort, requires surely afterthought and effort to pick it up, to form a habit, as you said. But once you are hooked on it, or once you feel the power of TDD, I would say there is no way back, right? So once you feel how easier, safer, and faster to write code with TDD, then you don't want to write code without TDD anymore. So personally, that was my experience.
I was serious about that warning.
Cool stuff. Here there's an interesting remark from Noe. I wonder what is your opinion of it. I still can't make myself write the test before the code, but I can't write new code anymore without writing a test for the previous one. I can't stand the accumulation of uncertainty. So what he or she does is that writing a bit of code, writing a bit of test, writing a bit of code, writing a bit of test. So what do you think about this approach, or what's your experience?
First of all, yeah, I'm tempted to say this is like an off by one error, but you're halfway there. You're starting to get the bug, the test infected bug of, yeah, you have to have that test there. It doesn't feel right otherwise. That's a big part of it, and that will help to kickstart your habit loop. But I mean, really, you have to ask at this point, why is it you can't make yourself write the test before the code? And maybe it's just reframing what that test actually is for you. If you've stuck in this mindset that a test is to look for bugs in existing code, which is how we've traditionally been maybe taught about these things, maybe that's the thing that you need to challenge. If you think of a test as that encoding your expectation, you've got an idea of what you want this code to do. Do you want to manually look for it, or do you want your code to look for it? Because if you get the code to look for it, you don't have to worry about it anymore. That can be a big relief. At least the first time. Like the second time and the third time you want the code to look for your test, well, that's saving you lots of extra manual work. So yeah, definitely look at your framing, I would say. I think this probably comes back to a psychological thing again, rather than a technical thing.
Definitely agree with that. And at the beginning, everyone who never used TDD, even if you have 10 years of experience of software engineering, and if you start, you try out TDD, you will struggle at the beginning, because it requires a mind shift, right? It's really a switch that you don't start with the code, you start with the expectation and you capture it in a test. You start with a minimal expectation, not a big one. So it really requires a bit of, it requires discipline, right? And if you don't follow TDD, you just write a lot of code. Maybe it doesn't compile, maybe it doesn't work, maybe it's not even testable. And after that, you realize that, all these things. And of course, you rework your stuff. And TDD basically prevents all these things, because you think of a small problem, you solve it, and you keep iterating and incrementally build up the software. So exactly, takes.
Yeah, you raise a really good point. When you're starting out, you shouldn't be trying to apply TDD to your main working code. Try it on these safe to fail examples. We call them coding katas, like I did with LeftPad. Do lots of those. Maybe do them like with other people as a group, as an exercise or something, but have some regular, what we call deliberate practice or deliberate learning sessions, where that's the thing you're focused on, and get yourself out of your comfort zone if necessary, because the whole thing is just an exercise anyway. And then when you feel comfortable with that and you think, right, this is the way I want to write code, only then are you ready to actually transplant that to your real working code.
Definitely. Being out of the comfort zone, that's the place where you learn. And with TDD, absolutely, it's worth. I mean, it's, the return on investment is pretty high. I mean, one of the highest in software engineering. So go for it, Noé. All right, here we have another question from Eric, an interesting one. This one. But as a user of the code, sometimes it's difficult to decide the interface of the code I need to implement. So many options sometimes. And what if I need to change it later? So what is your take? What would be the solution for this?
So there's two questions there, really. And the first one is actually just an advert for TDD, because you want to be the user of the code first before you're the implementer of it. Because once you've implemented it one way, it's much harder to change your course. So you want to feel what it's like to actually call your code, and again, listen to the tests. If the tests are saying, yeah, this is awkward to use, well, maybe rethink that interface at that point. That's giving you that opportunity. So if you're finding it difficult to decide on that interface, maybe just mock up a few tests ahead. So I would normally say, following strict TDD, you're writing one test at a time, get that one to pass before you go on to the next one. But for this sort of thing, what you're really doing is you're mocking up a design, and maybe just write more tests. And once you've written them, maybe comment them out and then get them to pass one at a time. You may still find you go down a different path, but it will give you that feeling of what it's like to use your code. You may need more than one test at a time to really get there. The other part is of the first question. There is a misconception sometimes that TDD implies no upfront design, which is not true. We don't want to have big upfront design that sort of locks down things to almost at implementation level, and then the rest is just a coding monkey exercise. That was something we sort of dabbled with more in the 90s, and we know that doesn't work. It's more of a collaboration between your design side and an implementation side. You start off examining the whole problem space, having a rough idea of your design and some specifics of it. And you may even, have a sketch of what the code's going to look like at that point. But you also need freedom within that for the design to breathe. It may go in a different direction than you expected once you actually start writing the code. So we know the phrase, no good plan survives first contact with the enemy. When you actually start writing it, well, some assumptions you had don't hold. So be prepared to change it. Don't be too married to your upfront design, but do have a design up front in mind before you start, at least loosely. There's a second question there. What if I need to change it later? A big part of TDD and the Agile movement in general, of which TDD is a component, is about embracing change. It's all about change. And in fact, TDD is based on this idea of constantly changing and evolving your code. You're not trying to write the final code. You're building up in little increments and seeing it fail and then pass. So by embracing change, your code is able to change more easily, because you can limit any breakages to just the parts that are affected. And if something breaks somewhere else, then you get that signal straight away. So you have that confidence to make the change. But also, because of that interplay between design and testing, you hopefully have got a more cohesive design in the first place. So any impact of your change is going to be much smaller and more contained. So again, gives you more freedom to change things and evolve them in line with whatever your needs are. So sometimes requirements change, that breaks some tests. That's inevitable. But if your cohesion is there, then any damage should be very minimal.
Excellent points. Couldn't agree more. And that's what really TDD encourages, right? Continuous refactoring, keep refactoring your code. Basically, you need to refactor. I mean, if you follow the TDD cycles, which I don't know takes some, approximately 1 minute, sometimes 5 minutes, sometimes half minute. then let's say that you should refactor your code in every minute, right? So of course you don't need to, but you have a dedicated phase, namely the refactor phase of TDD, to refactor your code. And TDD is, I would say, 90% is writing code by practicing continuous refactoring, growing the design by practicing continuous refactoring. So you had a very good point that be open to change, be agile, and throw away the code if you don't need. If you have a simpler solution, throw away. Never be emotionally attached to your code and how much time you invest in it.
Yeah, absolutely.
Here there is another cool question. Let me grab it in. So from Queen again, TDD purist, test everything, or TDD the parts that are the highest risk and see the most change? Interesting question. What's your take on this?
Well, I'll give you a software engineering answer to that. It depends. Yeah, it's easy to take the purist approach here and say, yeah, test everything. In practice, that's not always the pragmatic choice, especially if you're working with legacy code, where trying to get your legacy code fully under test is going to derail your whole project. Focus definitely there on the highest risk, highest churn parts. Sometimes even with greenfield code, you may have things that are just not very amenable to test. As I say, when you're test infected, when you're addicted, you'll find creative ways around that, but it might still be that it's worth to do it purely with TDD. Doesn't mean you don't have any tests. You should always have tests there at some level, and there are different things that might be appropriate in some cases. So if you've seen approval tests, that's something that can give you good test coverage very quickly, and much less intrusively than say unit testing. I've seen some people say they could do TDD using just approval tests alone. But even just system tests, we've got acceptance test driven development, so there's still a bit of TDD in there, but at a much higher level. You don't always have to have every line of code covered. Where you can, I think you should, but where that's actually past some point where it's really practical, I'm not so dogmatic on it, but usually find I can get much more under test than people think.
Yeah, agree on that. You shouldn't be dogmatic. On the other hand, every line of code you don't write tests for, then for those you can't be sure that it works, and you can't be sure that it will keep working once you add some change. So yeah, surely it depends, and absolutely, totally agree with that. But still, yeah, I mean, it's risky, and even I realized even the simplest lines of code, they contain the nastiest bugs, because we would never expect the bugs to be there. So yeah, it's a simple line, two line of code, a small function. Yeah, it's surely good. We just look at it and we say, yeah, surely not there. And after that, we spend hours on other stuff and we realize, oh my God, the simple code had the bug but it didn't have test. And it really happens, and it goes, it really relates to the fact that by reading the code we can't determine, we can't figure out if it works. We only know if the code works if we execute it. And there is a lag between writing the code and executing it, right? And this lag is the source of many problems. And basically that's the promise of TDD, that reducing that lag, right? Like writing the code and executing. Namely, you keep executing it within your test. So absolutely, the answer to this really depends.
Yeah.
On the other hand,
I might even throw in risk plane analysis. If you've ever looked at that, it's a very simple idea, but so often overlooked. Where you just have on one axis is how likely is it that something is going to go wrong. So something really, really simple and straightforward. Yes, you can still get problems in that code, as you say, but still, you generally look at the code and say, yeah, that's probably right. The other axis, though, is how serious is it if it does go wrong? And if you have something in the bottom left corner, so it's unlikely to go wrong, but if it does, it's no big deal. And it takes a lot of effort to actually put tests around that. That's where I'd say maybe I'll put the effort up in the top right. where it's likely to go wrong, and it's very serious if it does.
Mm.
If there's a trade-off, I will put the effort into those higher risk, higher severity areas. But in an ideal world, yeah, absolutely everything should be tested.
Love that. And that's the last sentence. So, Phil, I would like to say the huge thanks for the performance. It was great. I really enjoyed it.
Thank you.
So,
Thanks all for
again,
coming.
yeah, thank you for your performance. And before we end up, let me introduce the next session. The next meetup, April 9th, 2025. We will talk about the testing hyperpyramid from David Denton. It will be yet another exciting topic. So stay tuned and join us. So again, Phil, thanks a lot. And the audience, thanks a lot for staying here. And I wish you a great day further and see you in the next one. All the best. Goodbye.